Hello everyone, my name is Manny.
And I'm Liza. Thank you for taking the time to watch our video on the physics behind gliders and their flight.
We will spend the next few minutes going through both the lift and drag associated with wings and flight.
We hope you find the next few minutes interesting,
informative,
and entertaining. Hey, Manny.
Hey Liza, what are you working on?
I'm trying to understand the relationship between lift and drag. I was walking to the coop this morning and I saw a glider fly over campus. I know they don't have engines, but I don't understand how they can still fly.
You think that has something to do with the relationship between lift and drag?
Well, here's what I have so far. So the air has to move faster over the top because it's a greater distance, and the air wants to meet at the same time at the end of the wing. Because the air at the top is moving faster, it has less pressure than the air under the wing has. This must create a lift because there is more pressure below the wing than above it, right?
Well, sure, but that doesn't explain how flat-wing planes can fly, or how planes can fly upside down.
All right, now I'm confused. How does that work?
Maybe the air going over the wing doesn't meet the air going under the wing at the same time. Maybe it's about the angle of the wing instead. And even if the wing is flat, if the angle is different than the angle that the wind is approaching the wing at, then wind would go under the wing. Consequently, the wind that goes over the wing would have to curve in order to compensate for the width of the wing. But the wind that was above the wing already is not changed at all, so there is less space for the same amount of wind. The curve in the airflow that this creates is called the Coanda effect. That means that wind over the wing has to move faster.
Oh, I think I've played with a similar concept before in an online program. If air works generally in the same way that liquid does, then we know less space means faster, and faster and less space means less pressure. So the pressure under the wing will be pushing up on the wing with more force than the wind over the wing will be pushing down on the wing. That difference in atmospheric pressure must be lift.
Awesome, we've got it. But what about drag?
Well, the air that is being deflected downwards under the wing at the angle of attack, or the angle between the horizontal and the vector of the wing, creates suction, which is the lift force above the wing. But it also must push the wing back. So is that drag?
It must be. It's the only horizontal force being exerted on the wing.
So that means that because gliders have no thrust, the lift must be pretty big and have a relationship with the angle of attack. What's the nature of that relationship?
The greater the angle of attack, the less lift, and the more drag. So if the angle gets really great,
the plane might stall instead of flying forwards.
And if the angle is not great enough,
then the plane goes down. Great! Thanks, Manny. I think I have a better understanding now about the relationship between lift and drag.
Samesies.
Let's go fly some planes.